Hi, I'm Kody, and I'm a solo hacker. And during the hackathon, I made Flakebot, which is a agent that can build and deploy its own tools. Right. Here we go. So the general problem with agents is that you don't know what it can do until you run it, and you don't know what it's going to do until you run it. And so there's a bunch of different examples of this, but generally speaking, the problem is when you go ask an agent to go do something for you, it may or may not have the tools for it. And if it doesn't have the tools, can it install and build those tools so that it can use them? And if it doesn't have those tools, can it figure out how to build them itself in order to deploy them? And the runtime issues with agents are that they make them annoyingly bad, of that generally speaking they're not going to do what you ask them to. And part of the reason why is because it takes a couple feedback loops in order for it to get there, and normally it starts going down a rabbit hole. And then the feedback prone aspect of it is that because it kind of starts going down its own rabbit hole, it loses track of what it was originally doing, right? So a couple examples of this are, for example, if you try to use ChatGPT's data analyst tool, like I did this, like write and execute a Python program that creates a Schnorr signature over a message and verifies it. ChatGPT says it failed to install ECDSA, and so it tried to implement it itself, right? And so just generally speaking, like, you should never roll your own cryptography. Like, I work on Bitcoin as a day job, right? Like, do not roll your own crypto. Use professional open source cryptography libraries. But the reason why it can't do that is because the sandbox the AI agent is trying to test its runtime performance in, runtime actions in, doesn't allow OpenSSL, which is required for ECDSA. Right. Another example, right, is Open Interpreter, which is kind of like the most performant open source agent that you can run on your computer. The Open Interpreter can't install itself, right? And the reason why is because when I installed it on my computer, it can't identify what proper Python packages to do, right? So it starts going down through these rabbit holes of trying to install many different versions of Python. It's like, oh, hey, I'm missing this thing, or I'm missing this thing, and it just keeps going down these dependency rabbit holes. Right. A final example of this is just an agent trying to build and run a Python executable. This was in a Linux environment, and it tried to build a Windows program when it ran it. Right. And it doesn't know that until it tries running it at runtime. Right. So the solution is to move as much of the agent's tool use and development into compile time. And so writing in Rust, we can have tons of compile time guarantees of the correctness of the code, making sure that it passes all the tests, the doc tests. All the tests and the doc tests are inside of the actual code file itself, because Rust keeps all of that in the same code. So it works really well for passing them into LLMs, because you can pass the whole file and it gets the documentation and the tests as well as the executable. And then also using Nix for deterministic builds, right? So we can make the agent's tool use much better by writing it in Rust and then making a deployable binary with it out of a Nix flake, so that it can just deploy the Nix binary and you can get a reproducible deterministic build of the tool on whatever system the agent is acting with, right? So the big idea here is that if we have the agent build its tool with Rust, we can let it build and test its action and documentation at compile time, not runtime. And because it's at compile time, we can use something like Grok with really fast inference for doing extremely fast iteration on updating and improving the code as we're trying to make the tool better. And then if we spit the resulting program out as a Nix flake binary output, then we can let the agent dynamically deploy its own tools as needed and reliably interact with them. Because again, we have the compile time guarantees and we have the Nix flake deployment guarantees associated with the tools. Right, so let's jump into the demo. Right, so here we have a Rust application that I built that is going to take instructions from the agent. So in this case, I'm acting as the agent because this is the tool that the agent uses. On what it needs to build and use. Then it will go to crates.io, pull a binary down as a starting point, iterate on that binary by doing compile time checks that it's not breaking any of the tests and that the tests and that the code that it's writing actually works. Then run the binary as a Nix flake, and then allow the agent to interact with the binary that it spits out. And then once the agent is done using it, it's going to kill that tool that it just made. Right? So let's get started. We're going to run the instructions that the agent is passing is to build a simple HTTP server with post endpoints for adding and subtracting. Right? So here we go. Okay. So the first thing that it did is it cloned down the directory that it's going to use, right? So it found a tool that it wanted to use. It used like a hello world tool, which is just kind of like a super simple, basic HTTP server with Axum and Rust. Once it cloned it down, it looked for a Nix flake. It couldn't find one. So it fed all of the directory contents into Grok and then asked it to build a Nix flake for it. So the Nix flake that it built looks like this. And so this is some pretty fancy Nix that we have over here. I fed a bunch of documentation in as I was building this. And so what this will do is it'll start with a reference flake, but then what it'll do is it'll make sure that it can build the local Rust environment. So it'll pass in the cargo toml, it'll pass in some of the cargo files to make sure that it's got anything that it's going to need for it. And it's also just got some fanciness in it so that we can make sure that it builds on Mac, that we can make sure that it builds cross-compiles with the outputs, right? So if we look over here, I use Flakebot in order to do cross-compilation so that we get all the Linux distros, Mac, and Android as well out of this Rust build, right? And then if we're going to go up and see what it was doing, right? So then after creating the flake.nix, it'll start running cargo checks in the background so that as it's working and as it's rewriting different files within the directory, it's checking to make sure that it's not breaking any of the tests and that when it writes new code, it's adding a test for the code that it's running. And all this can be done at compile time. We don't actually have to run the program because Rust has compile time guarantees and compile time memory safety, race condition safety, like that kind of stuff, right? So we see here that the first time it runs the cargo check, then the program looks for whether or not the code that it pulled from creates.io satisfies the user instructions. And so it says it doesn't, so it rewrites the code. It adds the dependencies that it needs, and then it tries to run cargo check based off the new code that it wrote. And we can see that it failed, right? Because the new code that it wrote, we can see here is that it's not properly formatted Rust. It's got an unclosed delimiter, that kind of thing, right? And so that feeds back into itself. So it puts in the errors, the original, the new, and then it asks it to rewrite it again. And then we go in and we end up with another iteration of this. And again, it wasn't able to properly clean that out. That was just something I'm working with Rust, so it's we don't have any good agent frameworks like LangChain or whatever for pulling stuff out like this. So what it'll do is it'll just do another loop of trying to get it. And then we can see that after it rewrites it, then this time the cargo check passed. So and when it passed it back with the new main.rs, which is over here, it says that it satisfies the user instructions, right? And so we can see here that it added 2 endpoints to the program for add and subtract. It added the handlers for it, and then it added the tests. And so it's checking and testing that it's making sure that all this stuff's passed at compile time, right? So it can just sit there and iterate against Grok until it gets it right. Right. So then it builds the tool using flake.nix, and it outputs it as just a final binary, which we get the final binary right here. And this binary is, again, it uses Nix, so it's cross-compiled. It'll run on any architecture. There's no like, oh, you're missing the dependencies, or oh, you're missing X, Y, and Z things, right? It's built with Nix, and so it'll always work. And then it runs that binary. And so now the binary successfully started. It's running in a separate process. Then the tool spits back out. It says, okay, I built this binary. This is what it does. It says this program is a simple web server that exposes 3 endpoints, a get endpoint that returns hello world, and 2 post endpoints that add and subtract that take in a JSON payload with 2 numbers, and return the result of adding and subtracting their numbers, right? So the tool is instructing the agent on what it just built for it so that it can use it, right? So we can give this a couple tests. And so I just had it so that it becomes interactive. So we can write curl, right? Then we can try this one for add, right? And we can see that response is 5, right? So it wrote and added those to it, and at compile time, it guaranteed that it was going to be correct. And then it gave us the instructions on how to use the tool that it just built. We can try subtract, and that worked as well, right? Awesome, right? So now that we're done, right, I'm just going to have this be done, right? So I click done, and then it kills the process. And so now the tool is done being used. So kind of like in summary here, right, is that the agent asked the tool for something that it needed. The tool, which is Flakebot, built another tool, deployed that tool and then instructed the agent how to use it, we could use that tool, and then we were done, it killed the tool, right? And because we're using Rust, we can iteratively at compile time make sure that it's doing the thing that the agent wants us to do. And because we're deploying it with Nix, we can make sure that it always deploys correctly and we never end up with dependency issues, right? So that's the demo. So to finish up, future work. The way I see this playing out is that I want to have one-click agent Nix Flake-based tools and services deployments with Replit, right? So Replit currently has a templates architecture where you can start with a template and it gives you a dev environment. I actually don't want the start with somebody else's dev environment for my project, right? The thing that I want is to take a release from one of those projects that has a Flake output and just deploy based off the Flake output. And so Replit's already Nix-based, and so I can have an agent that says, hey, I want to use a Postgres database, or I want to use a Matrix chat server, or I want to deploy a Bitcoin node. And so because it can identify the flakes for it, it should just be able to deploy the flake with Replit, and now it has the service that it needs, use that service, and then kill it. And it can pay incrementally as it uses it, right? So the idea that I have behind this is that the agent is able to build and spin up services that it needs as it needs it in real time, right? So instead of deploying a template dev environment, as we currently have here, where you normally click on a template and it says like the use template, we could have deploy a tool or service based off a Nix Flake, right? So you deploy from the Flake. It's an awesome AI tool. Ideally, this would be API based so that AI agents are able to, for example, pay with Bitcoin in order to deploy this, have it exist for 7 seconds after you do the outputs, and then come back. And because it's all Nix Flake based, this actually wouldn't require many changes to the Replit architecture in order to make this possible, right? It actually would work really well with their current deployments architecture. So what are the big takeaways here? Is that AI tools should be written in Rust so that you can do compile time guarantees and you can do compile time checks for testing and documentation against the tool that the AI agent is writing and using. And then the agent tools should be deployed with Nix, because as you run an agent that's long running, it's going to need to get access to software that wasn't there when you first instantiated it, right? And as long as you can write it in Rust and deploy it with Nix, you avoid many of the issues that we have with current agents, of them running into the feedback loops and being super annoying, of going down these dependency rabbit holes or going down these issues with architecture. So if we can move the agent tool building to compile time with Rust and deploy it reliably with Nix, long-running agents can build, deploy, and use their own tools as needed. So thank you, and I hope you like this, and I'm very excited about it.